This Week in Radio Tech, episode 177, is brought to you by the Telos VX multi-studio talk show system. Telos VX is the first and only multi-studio talk show system designed for radio and TV broadcast production. Improved audio quality and cost savings from day one. On the web at telos-systems.com/VX.
And now, our feature presentation.
Twert.
Install an on-air talk show system with talent, call screening, and control rooms in different cities? Challenge accepted.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Doc?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land.
This is Kirk Harnack.
Christian Vang is my guest, describing the challenge he faced, plus insights into innovation and broadcast education.
You're dialed in to This Week in Radio Tech.
Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host. Glad to be here on episode number 177. Have you been with us for all 177 episodes? God, I hope not. We talk about radio technology. We talk about everything between the microphone and the beacon light on the top of the tower. All the audio stuff, RF stuff. This is the show where we talk about radio technology. And we cover some topical items from time to time. Occasionally we do some teaching. We've had episodes about how does AM work? How does FM work? What's digital audio and what are the different formats of digital audio? And so we try to bring you some interesting guests too. And on the show today, I believe we have a very interesting guest. This is a fellow that I've known for, about 8 years or so. I've lived in, maybe longer than that. I've lived in
almost
Nashville
a decade, yeah.
Almost a decade? Hey, let's bring him on in. Christian Vang, who is now, hey, Christian, welcome in. Christian works at ESPN. Christian, why don't you just give us the 2 or 3 sentence bio about yourself?
Well, I'm an engineer for ESPN Audio Technologies, which is a group that is based and kind of spread all over the country. We have offices in Bristol, Connecticut at the ESPN headquarters, Miami, Dallas, New York, Chicago, LA. And so it's a pretty big group. It's about 20 engineers total. And if ESPN comes out of your radio, out of your mobile device, that's what our group does.
Now, I noticed you didn't say ESPN Radio Group, and I expected that to be part of your title because for years we've heard of ESPN Radio, but you said Audio Technologies Group, and so obviously that implies a lot more than radio, and I think that's where our broadcast world is going. Tell us about the things that are radio and the things that aren't radio that ESPN is involved with.
Sure. Well, the things that are radio, obviously, are the radio network. That's the one big thing that everybody associates with ESPN radio. And I know a lot of the folks who might be listening are probably affiliates. The other part of our radio group, we also have 4 owned and operated radio stations across the country: Dallas, LA, New York, and Chicago, as well as 2 stations that we operate that are LMAs. And so that's kind of the traditional radio piece. But then we also have an incredible online inventory too, live streaming of the content that's generated on a multitude of our channels, as well as the content feeds out to places like SiriusXM, and then podcasts. I mean, and there's quite a bit of technology that goes into making all of those different pieces of audio available to the world in whatever that's disparate format might be. And
cool.
always looking to innovate, and there's always new technologies coming around the bend.
Yeah, and obviously streaming out to mobile devices is a huge one, and I think broadcasters like ESPN, and you tell me if I'm wrong, part of your goal and part of our goal as engineers is to let people enjoy our content in the lowest friction way possible. Just make it easy to get. You push a button and it's there. You push no more than a couple of buttons and it's there. Maybe you open the ESPN app on your iPhone and it's just there. The audio just starts. Like in your car for decades, we turned a knob and pushed a button. And if the station was already tuned to what we wanted, we didn't have to push a button, just turn the knob and the audio was there. But right now, with a typical smartphone app, you got to open it, you got to go to your favorites, you got to scroll through it and pick, the favorite you want to listen to. That's a lot of friction.
It is a lot of friction. I think as we go down the road, and as we learn more about what the audience wants, and as we learn more about what the technology is capable of doing, and its new capabilities that are coming out each and every day, there's this avenue to innovate new and easier ways to do things. I mean, it's kind of like if you think about the evolution of Facebook over the last decade. In 2003, Facebook was a relatively newfangled thing. And it was not exactly the prettiest. It wasn't the easiest. It was very simple. It didn't have a whole lot to it. It wasn't a really fantastic user experience other than it was a social network. And it was a social network that was very closed off to only a few people. But as time has gone on, it's become a social network that is available to more and more and more people. I mean, you saw in 2006, 2007, that era, Facebook opened to the general public. It wasn't just for universities anymore. And then all of a sudden you started seeing Facebook games, and then you started seeing, different Facebook advertising methods. And then you started seeing, different applications that could plug into Facebook. And so I think that's kind of what happens is, as these things evolve, as this technology evolves, people who are hip to it look at it and go, how can we do something with this? How can we make this cool? And how can we bring, specifically if you're speaking about a radio company, how do you take what we're doing and translate it to what they're doing? So I think the friction goes down over time as you get better at it, and that really comes through education, that comes through innovation. As you learn, you now have the knowledge to make something better. But at first, you're having to kind of go on assumptions and very little data.
Education and innovation. You told me earlier today, Christian, some of the things that you're working on with ESPN, and my mind was just kind of blown. A few days ago, or maybe a couple weeks ago, it was a few weeks ago, you contacted me on Facebook, and you had some questions about some capabilities of some Telos gear. And I said, yeah, I think you can do that. Yeah, we know it can do that. Nobody's ever done this before, but it should work. That's what I know right now. If I need to put you in touch with our developers or support, let me know. And then today we talked, and bang, my mind was blown with what you told me you guys are doing. Can you reveal any parts of this yet? What you're doing specifically with this call-in system, the Telos VX?
Sure. I'll limit the details just because it's still sort of forthcoming. But basically what's happening is we're distributing the roles of traditional radio amongst a lot of very disparate places. And sort of in layman's speak, that means imagine your call screener is in Walla Walla, Washington, and your talent is in Nashville, Tennessee, and you're connected by a VX system in the middle, and you make talk radio happen.
So for those who don't know, the VX system, that's a phone system that Telos, that's my employer and a sponsor of the show. Although the show's not supposed to be all about Telos, we do talk about the technology though, and this is kind of the cutting edge. So the Telos VX is a voice over IP, that is SIP. That's the protocol, a SIP phone system, like a lot of business phone systems, but it's tweaked to work for broadcasters. So what we have is we have telephone hybrids in software inside the Telos VX engine, and so that's where a line is selected to go on the air, and the highest quality audio we can eke out of that SIP connection is presented via live wire streams out the back of the VX engine. But now, Christian, you just said that you've got call screeners in one city and talent in another city, and I didn't hear from you from what city, if it's one of those two, where the calls are actually punched up to be on the air. So maybe you can kind of walk us through that.
The board operator is in another city in this particular scenario, so it's kind of unique because it's very distributed. Now, in full disclosure, I guess it's not fair to say this is all being done over the public internet, because it's not.
Right.
I don't think the Telos product is quite. I mean, it probably could if you think about it, and if you played with your routing right, you could probably get
Well,
it to do
we
that.
should point out that
Actually,
a SIP phone call can go over the public internet,
SIP can.
and SIP can, but that's down around 100 kilobits per second in total.
Right.
90 kilobits, 100 kilobits, right in that neighborhood. The audio is typically 64 kilobits per second, and then there's packetization on top of that. So the SIP calls can, although I would imagine that you guys are probably taking PRI or some kind of really high quality, strong local link to your telco provider. So that's taken care of. The live wire streams that come out of the back of the VX engine, that's carrying the caller's audio to an audio console, and then the audio console's mix minus audio back to the VX. Now, that's got to be in the same building, doesn't it? Because that's really high-speed data. Okay. That's in the same building on a local network.
Correct. The VX, in our particular scenario, the VX engine and the live wire audio node basically live in the same rack. They're right next to each other. Honestly, I don't know if it's a really great idea to try to shoot a live wire stream quite that far. The latency is awfully high.
Well,
because fiber, 1,000 miles of fiber, it's going to be about 40 milliseconds of latency anyway.
And the problem isn't so much latency, it's just that live wire, because it is low latency, and because there are 2,000 packets per second of audio for a low latency stream. The bottom line is you've got to have if you want to go some distance, that whole distance needs to look like a piece of Cat6 cable. And it can't have it can have routers and switches in there, but they need to be just massively transparent. So services like Metro Ethernet, that's a service that some telcos offer, and it looks essentially like a piece of Cat6 cable between here and there. That can work for live wire streams, but you got a lot of juggling to do there, so it's better to have all the live wire in one place, which you do. So you got your mixing console, control room, and the VX system in the same local area network, right?
Correct.
So the other thing,
it's Kurt. I think I probably need to throw it out there. It's actually a little simpler than even that. The output of the VX engine live wire is crossover cabled into the audio node. I mean, it is the most local area network you can build.
But what's curious though is this notion of your call screeners being off-site, and a lot of folks look at here. I've got one right behind me here. This is the Telos VSet, and that's the controller phone for the VX engine. And fortunately or unfortunately, this is not a SIP phone. The audio to and from the phone isn't session initiation protocol, because this phone isn't really on that side of the equation. Broadcasters have a completely different need than, say, a business user of a telephone. A broadcaster is controlling hybrids, not transferring calls to and from a hybrid. And a broadcaster needs to have updates, instant updates on the status of every line. Is it screened? Is it ringing in? Is it on hold? Is it on screened hold? How long has it been on hold? And what's the caller ID information? Is this person in our phone book, et cetera, et cetera? And so these VSet phones are actually connected to the VX engine using not SIP and not LiveWire, but kind of in between those two. It's kind of a quarter rate version of LiveWire. And so let's say it's 400 kilobits per second for the audio in each direction, plus the control data that goes back and forth between the VSet and the VX engine. Well, you can send 400 kilobits per second audio, and it's not guaranteed to be low latency. There's a little bit of buffering going on there, but you can carry on a conversation. My point is this: if you're going to remote part of a VX phone system, it's going to be this VSet here, and it's going to be, it could be somewhere else on the internet, or preferably on your WAN, which is, I'm going to let you explain that in a second. But this is very doable. You can put that phone remotely, not quite as simple as SIP. It's got higher bandwidth requirements, but it certainly can be done. And Christian, I think you were going to talk about that and talk about the real challenge was getting the switches and routers configured.
Right. Well, the funny thing with the VSet is it's actually a very simple device. Like that's, and this is not a plug for the VX at all. The VSet itself is a relatively simple device, and it's so simple that it really doesn't even have a whole lot of internal smarts or settings to it.
Right.
You basically plug in an IP address, a gateway, a subnet mask, and it's going to look for the engine. What that limits you to is, unless you've got really, really, really stout point-to-point internet-based connections, you're really not going to be able to pass that over the public internet. And it's because there's really no quality of service there to make sure those packets get from point A to point B.
Oh, right. You're right. Yeah.
And RTP streams, audio streams, are not dependent on QoS to operate, but they operate better whenever they're in a managed environment.
Hey,
I think it's probably the best way to
I got
say
a
that.
presentation that I did here on Twort, and I did it at NAB, and it's going to appear, I believe it's going to appear in Radio World before too long. And the answer to all your IP audio problems, use a perfect network. That's it. Just use a perfect network and it'll work. And isn't that our problem? We don't have perfect networks, but in your case with ESPN, you guys have corporate WANs, and you are able to manage them in a way that you get near perfect operation out of them.
Correct. Yeah, our network services teams are really good. They probably some of the best out there, I think. And in terms of the things that they've been able to bring to the table, I've been pretty impressed. Just at the ability to say, hey, this is my requirement. This is kind of what I need. I know this is a little bit of uncharted water for you as a networking person, but they've kind of rolled with it, which has been really good. Because sometimes I know that as IT people on the IT side of the equation, a lot of folks get really nervous whenever you start saying, well, I've got this special application, and I think, and it's being able to break it down and say, okay, look, so here's the sum of all the parts. The Livewire thing, that's going to live on its own private side. We're not going to put that in the outside. We're not going to put it out in the wild. You don't have to worry about, me flooding some building's traffic with Livewire packets.
Yeah.
I think whenever you can put that fear to rest, you can kind of move forward with your ideas. But, and then being able to explain, hey, this is exactly what it does. It takes a lot of research to do that, though. And, like you said, my initial conversation with you was some basic questions, and then that turned into a conversation with Jeff McGinley, and turned into a conversation with Joe Talbot, and it turned into, it was this conversation that kind of went, well, hey, can you do this? Well, in this scenario, if I was to have this piece and I was to do that, would that work? And then getting the system actually into the lab. I created basically a lab scenario that emulated what we were going to be doing. And so I created this scenario in my shop and tested it out, and it worked. And so it kind of made sense, and I was like, okay, it works here. Now let's kind of do the real test. Let's put it on 1,000 feet, 1,000 miles of fiber, and see what happens.
Yeah.
And it's so far it's been working pretty good. We've been playing with the VX Producer software. I think it's pretty cool. I like the fact that the server is all built into the VX engine. There's not a need for an external server to do some of that kind of stuff. I do kind of wish the VX engine had like a producer light web interface, maybe, so that say you have a talent who's out in the field and all they have is their iPad, they can pull up this producer light web page and actually be able to put calls on the air, see what's been screened, not necessarily have all the soft phone capability that the VX Producer has, but or the recording capability or anything like that, but just something really simple.
So I think what you're talking about is a call screening software, and our friends at Comrex do this in their Stack product. They have a call screening system that is based on HTML. And maybe there's some Java or JavaScript in there. I don't know. But you'd browse into the controller, and you get the call screening right in front of you. Now, there are some challenges with that in terms of updates. A lot of times an app can give you a better experience than a web page. But I agree with you that a well-designed web page could be a basic call screening software. Updates would probably not come as quickly as with an app, but still it could be useful. And I'll put a call out. I can't say that we're hiring at the moment, but it would be nice to add to our cadre of expertise at Telos by knowing about some programmers out there, some coders who are particularly good with HTML5 and making stuff happen, making it look like an app back and forth on your browser. So again, I'm not sure I'm taking applications, but hey, if you do that kind of stuff, or you know somebody who does, you might want to make yourself known to me. And over the long haul, I think we might be able to do some business. We certainly have plenty of coders at our place, but a lot of our guys are way down there in the C plus and the C++ stuff, and man, they're down in the shift registers, and we're looking for some talent to do a little prettier stuff on the higher level. So Christian, I want to eventually get to the part of the conversation here where you tell me a little bit more deeply about your conversations with IT and how you guys got on the same page to make this happen. That's a challenge at a lot of broadcasting outfits where IT and engineering are separate entities, and they don't have coffee together. So
right.
I'd like to hear about that. What in your process of investigation, what led you to the conclusion that this can work? Was it your lab setup, or was it something else?
I think it was a combination of labbing out what I needed, because I tried several products, and it was it was kind of a taste and see, because this particular application is not something that people are doing. And not doing it at the scale. And most people never will, because we think about it, in most radio operations, a radio station group even is contained to one building. And, they might have a facility across town that might be connected by fiber, but their latencies aren't nearly as high. I mean, their latencies are on the, 2-3 millisecond level. And so their situations are entirely different. This was just kind of a very unique application, and it took truly kind of going to every vendor who does something like this and saying, hey, do you have a product that can meet this requirement, this requirement, this requirement? And if you do, let's talk about it. I really need to know a lot of details, because I'm going to have to go pitch this to a bunch of networking people and say, I want to put this product in, and here's what it does, and here's what I need, and here's how I expect it to work. And and you can't really do that necessarily without playing with it.
Here's a question that pops to mind. Have you ever worked at a radio station where the salespeople would sell a remote from a place that was impossible to get a signal out of?
Absolutely.
Salespeople would sell impossible remotes. Okay, so how did somebody at ESPN come up with the idea that the mixing console is going to be in city A, the talent in city C, and the call screeners in city B? I mean, who would begin? Okay, maybe the talent is elsewhere. Okay, and maybe they're phoning it in with a Comrex or a Telos IP product. Or they're using ISDN with a Zephyr. That's been done for years. But who came up with this 3-city idea?
There's some questions that I don't ask, and it's just because it's not my place. I say challenge accepted, and
well, good for you.
Find a solution.
I'm gonna, hey, challenge accepted. That could be a good slogan for somebody. I got to write that down. Challenge accepted. I think I've been looking for a slogan to go on Twort T-shirts. That could be a good one. Challenge accepted. That sounds like Chris Tarr talking. He's not here yet, is he? He was trying to make his way into the into his office. Nope, he's not online yet. Doug, he's missing out. He's missing out. Okay, so all right. So you had the scenario. You accepted the challenge. You looked at different systems and how they could work. One of your vendors you called was Telos. We said, yeah, we think that can work. People are doing something a little similar, not quite to your extent. Now, I want to get to this part about the marriage of your audio engineering and the IT guys.
Right.
Talk to me about that. How did you approach that?
Well, one thing, whenever you're part of a company like ESPN, and this isn't going to be every scenario. I mean, this is kind of a handful of isolated cases where it's going to be, it's going to be a major network. It's going to be, it's going to be somebody like NPR or CNN or ABC. These are going to be your people who are typically doing this. You're not typically going to do this on the local station level. And so it's one of those things where you kind of know who all the players are. You know who you have to approach. and you put all those people in a room and you kind of present your ideas, and you have to trust that as soon as you spit these ideas out, every single last one of them is going to poo-poo the idea just right there. And and sometimes they get it and sometimes they don't, and so that's whenever you have to come back and be able to defend your argument and say, no, well, this is the reason we need to do this. We can't, we're not going to tell programming how to build the show. We're just going to facilitate what they've asked for. And so it really, and I will say at ESPN, the thing that really kind of makes our folks unique is that everybody is gung-ho to help. And so as soon as you take an idea like this to in this particular group, there was a network engineer, there was an engineer from the fiber side. It's a group we have internally called Transmission, who handles all of our fiber networks, and then and then a project engineer who was kind of overseeing the top level stuff, and and you take all these requirements to them and you say, okay, for phones I need to do this, for audio I need to do this, for space I need to do this, and you kind of lay it all out there, and you toss ideas around. And I know there was a process that went on for about 3 weeks where we were throwing Visio diagrams back and forth and going, well, could this work? And then, somebody would send one back that says, well, we don't really support that, or we don't really like to support that because, it has this challenge or that challenge. I mean, we've done it in the past, but it's been really problematic. And so it's good to be able to draw from that experience and say, you know what? For instance, with the VX, the VX is on the corporate WAN, right? But all of the handsets and the VX engine are in their own VLANs.
Oh,
and it's because they generate their own traffic, and we don't really want that traffic spewing out into, say, a server VLAN or into some place where it doesn't need to be. And so you have to look at that challenge and you have to say, okay, well, we know that it's going to generate this kind of traffic. We can create dedicated routes between these places, and we can really confine that traffic to one specific route. But it's taken them doing other projects where they have done something very similar and really had a bad experience with it and said, well, this thing has become this monster to support, and I don't know if this is really the best way to go for you. And so, for instance, in this project, there was one particular vendor we were working with who has a device that's very similar, except it won't work on a layer 3 routed network. It has to be in the same broadcast subnet. And so we kind of hemmed and hawed, and we looked at, well, how could we do this? And we started looking at third-party devices. And the more and more and more we got down the road with this particular product, the more we realized that by the end of the day, we were spending tons of money to try to make a product work that wasn't really designed to do what we were doing anyway. And and so it would have been a giant science experiment to begin with, and it just didn't make sense.
Yeah, I see. Yeah,
but you don't know those things until you go to somebody who has more experience doing similar things, who can tell you, hey, we did this project where it was all layer 2 over fiber, and we had this problem and that problem, and it was hard to troubleshoot, and so it would be better if we did routed layer 3 and we did this and this, and I think that's really important to be able to draw from that, to be able to say, okay, those are your requirements, challenge accepted, and and you come back and you say, okay, well, how about this? And so you throw those kinds of ideas around, but it's got to be an environment where you trust people and where you trust that they have your best interest in mind. And, and at ESPN, I really feel like people do. You go to a group and you say, I've got a problem with a firewall and it's doing this, and it is just making my day go bad. and immediately somebody's on it, somebody's looking into it, and it's and they're an expert at what they do, and so you can rely on the fact that they're very knowledgeable about it. You can describe the problem, they can fix the problem.
That's great. That's great to have those kind of IT, not only the IT as a resource, but IT people who want to help you solve the problem. And so you're proving that so much of what radio engineers, audio engineers do now begins to depend on IT infrastructure. And there's a lot of engineers out there, myself included. I mean, I'm the IT guy for our radio stations. And, there's a lot of things that I still don't know. I know enough to get a few things hooked up, but you want to do something fancy. And man, I need some help. So great to have these people in your back pocket, or at least, at your disposal may not be the right word, but they're going to cooperate with you because they want to get the show on the road too. I mean, hey, who doesn't want to watch the football game?
I think there's in an organization like ours, it's a team. I mean, we talk about our audio engineering team. We talk about the IT team, and ultimately we're all a part of Team ESPN. And so it's, at the end of the day, it's not about us. It's about the end product. It's about the viewer, the listener, the sports fan. And that kind of translates all the way out to the mission that, we serve sports fans anywhere, anytime, sports reviewed, watched, listened to, talked about, whatever. And so, and that's, I think that carries through. Everybody has that in mind. Everybody's very clear about that. And I think that because of that, we work better together.
That's cool. Hey, you're watching This Week in Radio Tech. I'm Kirk Harnack, your host, and our guest this week is Christian Vang. He is an engineer in the Audio Technologies Group at ESPN. Christian has been a broadcast engineer at a number of stations, large stations and small alike, a few stations here in Nashville, and he's traveled around a bit, and now headquartered over in the Dallas, in Texas area, but been working around the country with ESPN. Hey, our show is being brought to you by the Telos VX. How about that? Here we talk about the technology, and there she is. The Telos VX is a SIP-enabled phone system, so it can take SIP phone calls right out of your SIP-enabled PBX or SIP trunks or SIP client lines coming from your SIP telco, whatever telephone provider that you want to use that provides SIP services. And there are a number of them. You can use the good old incumbent phone company that may be in your town, city. They may be able to provide you SIP service, but oftentimes the incumbents are kind of the last ones to the party, and you can get oftentimes quicker or better SIP service from alternative providers. Not recommending any in particular, but there's XO Communications, and there's plenty of national providers that will provide over your own internet connection. So there's plenty of places to get SIP. You can have your station's phone numbers, including high volume numbers, ported or sent over to a new or different provider who's going to provide you your phone calls coming in on SIP. And you can also take more legacy connections like ISDN PRI, ISDN BRI, T1 circuits. You can bring these into a device called a gateway. And there's all different brands of gateways. At TELUS, we recommend those from Patton. They do seem to be pretty robust, but there's other ones as well, and you can bring your own. And then that gateways turn those legacy services, including POTS lines, into SIP. And you run that into your TELUS VX. And the VX is an engine into which you can define a number of studios, a number of shows. So you can have different phone line setups for a studio. You can move a show from one studio to another studio if you need to. Hey, today, the Dr. Carl show needs to happen from Studio B instead of Studio A. That used to be a nightmare with older phone systems. You have to patch phone lines around. It's just a big mess. With the VX, you go to one of our VSets and you punch up the show that you want to do, and bam, the lines appear and you're good to go. The TELUS VX, again, can handle multiple studios, multiple phone lines, of course, multiple show definitions. And the next thing you're going to like is the audio quality. It is unbelievably clear. There's a large television network who put the TELUS VX in. They take calls from reporters, especially in some interviews, and their chief audio guy told us, "I've never heard phone calls sound so good." Now, remember, they're still based on G.711 in the end. Ordinary POTS or a phone call or cell phone calls oftentimes are based on slower codecs than that. But the point is this. It's going to make your phone calls sound as good as possible, and we have expansion possibilities in the future. Right now, the TELUS VX even ships with G.722. That means you can take a smartphone app and call into, say, a SIP server like an Asterisk box, and have that move the call into your Telos VX as a G.722 call. You get 7 kilohertz of audio from a line on your telephone, on your VSET, and you can put that on the air. There are stations doing that right now for their remote crews and their news people that are out on the street. So when they make a report from the field, it's 7 kilohertz of audio. And coming down the pike, phone companies in Europe and one here in the U.S., T-Mobile, have gone to starting to use HD voice. That's typically the AMR wideband codec. And this phone right here from Samsung, the Galaxy Note 2, it has the HD voice codec in it. So does my wife's iPhone 5 on the T-Mobile network. When she and I make a phone call, it's 7 kilohertz of audio. As I've told folks, it's the first time I've ever been able to understand my wife's mumbling on the phone. And we're going to be able to bring that to you in the Telos VX. So that is coming. You'll be able to make an ordinary phone call, not a special app, but an ordinary phone call from phones of the future, or maybe T-Mobile phones now, into your Telos VX and get 7 kilohertz of audio quality from your callers. So cool. Check it out on the web. If you're doing 3 studios or more, you ought not buy individual phone systems for each studio. Look at the Telos VX, because for 3 studios, it starts to break even, and 4 or 5 studios, and man, Telos VX is definitely the way to go. If you're already an Axia user, it costs even less. You save thousands of dollars if you already have that Axia gear in your studios. Check it out on the web. It is at telos-systems.com/VX. I appreciate very much Telos is sponsoring This Week in Radio Tech. And our guest, Christian Vang, engineer for ESPN. We've been talking about the technology behind the Telos VX and in the IT department that's allowing them to operate the way they want to, with talent in one city, call screening in another city, and the phone calls themselves, the audio itself, in yet a third city with the mixing consoles. Christian, what else? I've gone on here for 5 minutes. What else has come to mind to tell us about this setup? What's interesting as an engineer or an IT person about how all this is working?
Well, I think probably with this project, the most challenging thing is to keep it simple. I want to say without getting into a lot of real particular things, because I can't, but
I hear you.
there was a lot of phases in the design process where we would have ideas and we would say, let's do this and this and this and this. It's a traditional studio, and and we had to kind of circle back and go, that's a lot of overhead. That's a lot of things that could go wrong. And so let's pull back and let's look at it again and try to make it even less faulty. Let's try to make it more fault tolerant. Let's try to make it more robust. I think that was probably one of the biggest challenges of the space where we've been doing some of this project. I mean, large pieces of this already existed. And so we didn't really we didn't have to generate a new control room. We already have control rooms. The studio space, on the other hand, was new. And then the production concept of putting call screeners, basically at home, that's pretty revolutionary. I mean, you don't really run into that very much. And so I think that particularly the connectivity has been an interesting challenge, because it is not dealing with just Metro Ethernet. It's dealing with, thousands of miles of fiber, and and the latencies that exist with that. And so taking a lot of those things into consideration, fault tolerance in places where you really can't be fault tolerant, such as, whenever you've got a producer, for instance, who's working off of a VPN. This is one of the scenarios we threw out there.
Yeah.
Was, what if we were to take a producer, put them in their bedroom with a VPN concentrator and a VSET and a copy of VX Producer? How else is this going to work? Realistically, are they really going to be able to do their job? And it's and it created this interesting challenge. So we were able to really kind of experiment a little bit and kind of come up with a base set of requirements and say, okay, well, in order for that to happen, these things have to be true, and And those are the kinds of big questions you kind of have to ask in a project like this. Is, well, what are we trying to accomplish? What is things that we're adding just for the sake of adding, or things that we're doing because we've always done them that way? And
Mhm.
how can we innovate beyond that? And how can we kind of look at this and say, well, the reality is that if this producer is working at home, um, their broadband's probably going to be this, and their computing equipment's probably going to be this, and we need to make sure we're going to do this, and this, and take away all these other layers, and there's all these things that kind of you look at from sort of the broad perspective, and that's being really vague, and so that's kind of tough to read
I
through, but
understand. I hear you.
uh,
Well, you
you
it
know,
sounds like you went back and instead of getting mired in individual problems, you at least once in a while step back and say, guys, what is it that we're really trying to do here?
yeah, you
And
have to
if
ask that question.
you sure do. It's
That
it's 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 important not to get bogged down in thinking about the way we always used to do something. It's so refreshing, helpful, and necessary to just back up and once in a while say, what is it we're really trying to accomplish here? And you might end up thinking of some totally different way you can bypass a whole lot of the crud that maybe you used to do or you thought was necessary to be part of the chain of operation or the signal flow chain. There can be ways to really simplify it, and it's a great question to ask. Christian, earlier you and I had discussing the following topic, and that is education and innovation and their places and their importance to engineers. As engineers try to grow in their career, we try to bring some new engineers into the field. Let's talk about that for a minute. Tell me what's on your mind foremost in terms of education of engineers and their ability to innovate.
Well, it's really interesting you ask about that. It's kind of an area that I've grown really passionate about. I think in the last 4 to 5 years, is really, what are we doing to train people? What are we doing to teach people how to be broadcast engineers? And because when I was in college, there really wasn't a lot out there. We're in this sort of generation 4 going into generation 5 group of engineers, as we would say. And because generation 1, they were the early adopters, they were the ones who found the spark. There's generation 2, which was the group that made AM glorious and pushed it all the way up through the 70s. There was the group that came along in the 80s that made FM king. That's generation 3. Generation
Mhm.
4 was the group that really started to take hold in the late 90s, early 2000s. And every time you see one of these eras, you see these groups getting smaller and smaller, and you see the time frame in which they operate shrink. Because the first group, I mean, they operated for about 40 years, and then the next group only operated for about 35 years, and the next group only operated for about 25 years. And so you start seeing this sort of logarithmic curve downward of, you know, the time frame that these generations are lasting is a lot shorter. And I like to think that it's because the technology is changing so rapidly. Broadcasting as a medium has changed dramatically in the last decade. Um, just the technology alone. I mean, in 2000, could you have imagined? I mean, you think about it. Okay, in 2000, our favorite phone system was the Gentner TS612.
Yes. Uh-huh.
It was a very, very analog device with a couple of basically basic stamp microcontrollers in it.
Mm.
Um, you know, it's a pretty simple device. It operated on analog phone lines. And then you start getting into some of the more digital devices that came out in the early 2000s. Telos was a primary push or a primary proponent, primary really sort of founder and push generator for some of the new phone systems that were out there. You were the first guys doing BRIs. You were the really the first ones to start bringing in complete PRIs and managing them
Mhm.
with the system like the 2101.
Yeah.
And then, and so you have that sort of generation of technology, and that has all given way to this new SIP technology. The phone company did not fundamentally change between 1940 and 2000. And then all of a sudden, you see the technology change incredibly rapidly over the last 20 years. And I think is what is driving a lot of the change in broadcasting. And so this is where the engineer fits into this is you have to be able to innovate as these things change in order to stay relevant. I mean, it's I think RF engineering is like one of the most fun things ever. Like I love RF engineering, and I love talking to old broadcast engineers. Just I can't ever imagine doing some of the things with AM that they have done. You know, but
Yeah.
then I
Yeah.
think they probably look at some of what the current generation of engineers does, and they go, well, we've never imagined that all of our phone calls would come down an IP trunk. You know,
Right. Yeah.
so
Where do I put my butt set?
I don't think any one is any worse or any different or any better or that there's any sort of comparison between the two. They're just really different. The generations of engineers that have come along are very different, and now we're moving away from an engineering generation that is totally engineering driven and they're IT driven. And it's because that's everything they know. I mean, you look at the vast majority of electrical engineering schools in the 40s, radio was what they were teaching, right? Because radio was the big technology of the time. Whereas if you look at electrical engineering programs of today, they're computer driven, they're microcontroller driven. It's focused on problems that exist today. And so the broadcast engineer, I think, has to kind of do the same thing. And the way you do that is through education. You can never stop learning. You can never stop asking the big why question. You can never stop asking, you know, who do I need to talk to? Where do I need to go? Where am I going to find that piece of information? Because if you do that, what ends up happening is you're going to get left behind, and you're no longer going to be able to innovate quite at the speed or at the rate that somebody who is on top of it is. So,
Gotcha. Yeah.
a lot
Yeah.
of
Now,
lot of fun thoughts there.
well, it's a lot to digest. Education certainly is key, and so I've always been a curious person. I've been very fortunate to work for Telos. If there's a technology I need to learn about, either we have a piece of that at Telos, or I can buy something, examine it, share it with the R&D guys. But a lot of engineers haven't got time to be curious. They got a transmitter off the air and a remote and a studio that's broken down, and they're running all over the place. I just wonder, from a practical point of view, how do we get engineers more educated into the techniques and tasks that they need to know, or at least, I guess it's almost as good to know who to call. Because, hey, Kristen, you've mentioned that it wasn't you who set up all this IT infrastructure with your new phone system at ESPN. You depended upon the expertise of other guys who have that knowledge. And your needs
Right.
are pretty great. So, your needs are greater than the needs of, say, a small town radio station like the ones that I'm part owner of in Mississippi and in Samoa. We don't need the kind of IT that expertise that you have available to you. Although we do need to, get some VPNs going between the different sites so that we can hit a button in one city and print to another city and do that over the public internet. So I guess. Back to my original circle back around, how can engineers get the education that they want? And I think a lot of it is you got to be curious. You got to go seek the knowledge that you want. It's not going to land in your lap.
Absolutely. I think, a lot of it is being willing to head out to what I call the great Google machine and start with a topic and just say, today I want to learn about SIP. Going into this project, I knew very little about SIP. I knew what it was. I kind of knew what protocols it used. I didn't know what ports it operated on. I didn't know that much about it because very rarely does telephony really cross my desk. It's not something that I really think about that much. But going into this project, it was one of those where I had to say, okay, you know what? I'm about to have to embrace this thing like by the horns and really figure out how this is going to work. So I need to learn everything I can learn about SIP. So it's a trip to Barnes and Noble to go pick up a bunch of books, and it's Google, and it's finding podcasts, and it's just some research. I don't spend my every spare waking minute researching. It's just you have to kind of find those moments that you can really kind of pour into that. I read a book not long ago, a fellow by the name of John Acuff. It's called Start, and he makes a really interesting point that if you're really passionate about something, you're willing to start early. And so I've kind of taken that to heart. It's like, okay, you know what? Every day when I get up, I'm going to spend the first 15 minutes of my day reading something that's going to enhance the way I work. Right? So, it might be the Sip for Dummies book that I picked up at Barnes and Noble. It might be the Cisco how-to guide that I picked up along the way at the used bookstore, because Cisco books are really expensive, just so everybody knows.
Yes.
And so there's kind of this need to to make time to do it. And it's whenever I'm at the gym running on the treadmill, hey, you know what? I'm going to throw on that podcast. It's not quite as awesome as the rap music they're playing in the gym, but I'm going to learn something while I'm doing this. And I think that's really where you do it, is you kind of have to make time for it, and you say, okay, you know what? For this 15 minutes a day, I'm just going to learn something that I've never known about. And what's really interesting is a lot of times, as in the process of learning, it takes you to so many other places that you would have never imagined that you would go. So in this process of learning about SIP, I actually ended up going down this really fun little tangential rabbit trail of reading about people who were spoofing the phone company for all these years. They were basically the early hackers.
Yeah.
Fascinating. I mean, I never thought in a million years people would hack Ma Bell. Certainly it's not something that I'd ever desire to do, but it's interesting that there are people who are out there to do that. Another really interesting rabbit trail that came from this was looking at how the government does point-to-point phone calling. And I was Googling, and I ran across this paper that somebody had written about point-to-point communications in emergency situations. And, and it was just sort of this fascinating read. And it was only 20 minutes of my time to read it, but it, at the end of it, I kind of walked away from it going, there were some interesting ideas in that paper, And that's kind of how ideation starts. You start with this core thing. I have a need to learn about SIP, but without understanding the history and without knowing what all these terms mean and knowing where SIP was derived from, you really can't get a good grasp of what they're trying to do. You just understand that it's protocol and that it requires these things. But now you can actually have a conversation about it where like talking to the telecom engineer as we were setting up the VX. There was a point where, he started throwing out a bunch of terms. The ability to be able to not stop him mid-sentence and go, huh? But to be able to say, you know what? Yes, we need a hunt group that does this, and it needs to do this, and it needs to communicate with these DIDs. Without reading the book on SIP and without going down all those rabbit trails, half those terms would have been foreign.
And and it's not just a matter of lingo, it's the idea that the lingo embodies.
Right.
So that when you say I need a hunt group, you don't have to spend much time explaining what you need. If you tell a telephone guy or an engineer, I need a hunt group, he knows what you're talking about. Or if I say, hey, a really cheap way to make your own hunt group using SIP, subscribe to a total of, let's say, 6 Vonage phone lines using 3 Vonage phone adapters, and go into the setup for that and tell them that if this one's busy, go to this one. And if that one's busy, go to that one. If that one's busy, go to that one. And guess what? You've just made a poor man's hunt group.
Right.
And on the air, you give away one phone number, and guess what? They fill up until they're all full.
Right. Well, and the innovation really kind of, I think, starts to happen once you can cross that boundary of knowing. SIP, for instance, is a relatively newfangled thing. I mean, it's not, but it is, and it's funny because you start talking SIP, most network engineers kind of look at you and go, "Oh, that's that phone protocol." And and then you go to a firewall guy and they just kind of roll their eyes and they're like, "Oh God, please, not SIP," and being able to kind of speak intelligently about it kind of makes a lot of difference, because you can approach that conversation with, "Hey, so I know you hate SIP and I know here's why. Here's what I need you to do." And I'll buy the drinks afterwards if you'll do that. you know and I think, without knowing, though, you can't really do that. um and that's IT innovation, I think, forever is going to work like that, where you learn and then you implement, and learn and you implement. um and our earliest broadcast engineers, they worked the same way. The Generation 1 people were exactly the same way. Interesting book I picked up at the WSM transmitter site many,
Oh,
many, many years ago. And Watt Harrison was the chief engineer at the time. Let me have this book. And so I still have it. It's one of my most treasured texts that I've ever found on the topic of radio engineering. And it's this 1932 Radio Man's Guide to Engineering by Terman. And it is, you start flipping through the pages and you get about 40 pages in, and he's talking about how to wind your own resistors and how to make your own paper film capacitors and how to wrap your own transformers. And then you get to the part where he talks about RF, and you're flipping through and he shows this table of frequencies, and it's 0 to 10 kilocycles is this, and then 10 kilocycles to 20 kilocycles is this, and then he gets up just past the AM band. I'm thinking it's like 20 kilohertz, maybe. It might have been about as high as a megahertz. He makes the comment there. He goes, "Nobody will ever need anything past this frequency." Obviously, things have changed.
yes.
And I, that's innovation, though. That's somebody, some kid somewhere just came out of college, has been winding his own resistors for the last 4 years, and he comes out and he goes, "No, dang it, I want to put something up at 4 megahertz." and and I don't know how I'm going to do it yet, but challenge accepted.
Yes.
I am going to figure out how to make these components do this and create a filter that will pass these frequencies this way. And then all of a sudden the world has changed, you know? But he could have never done that if he did not read Nicholas Terman's seminal book on winding your own resistors.
That's great. Oh man, I love it. I love it. Good advice. Hey, if I could share something, there's a huge number of educational videos on YouTube, and I don't mean just Khan Academy stuff. I mean, there if you look for SIP tutorial on YouTube, you're going to find half a dozen talks about SIP from 10 minutes long that are kind of commercials for whoever's sponsoring them, to a 20 or 40 minutes or an hour long tutorial from somebody who just wants to teach the concepts. So YouTube is another good source, if that's a method that you like to learn from, watching somebody talk about it.
Yeah, video learning is a great way. I got to be honest, like the first level of Cisco certification, I totally did with audiobooks.
Oh, yeah.
Because it's dry reading and I fell asleep every time.
Hope you didn't fall asleep on the audiobooks, because then you're probably on the road.
No.
Hey, Christian, we're gonna wrap it up here. We've been going on for an hour, and I really appreciate you sharing some of your thoughts, and I especially like your thoughts about how we as engineers, to further our careers, to further our craft and our industry, we have an obligation to learn what we can and be curious about the world and accept the new challenges. And you've said several. In fact, that's going to be the title of the show: Christian Vang, Challenge Accepted. How about that?
I like it. That's perfect.
That'll be our show title. Christian, thanks again for being with us. If folks want to be in touch with you, you're not terribly secretive. I think you appear on Facebook from time to time.
I do. I've been known to make an appearance, and usually it's showing pictures of my cats or, talking about whatever I'm doing that day or whatever crazy thought I'm having. So yeah, it's kind of an interesting time. So feel free to look me up there, and can always be reached via email, vang.christian@gmail.com.
Cool. Hey, when the project's all done at ESPN and it's been on the air a while and everybody's happy and the bugs are worked out, why don't we get back together again? You can describe the challenges that occurred and what your next accepted challenge will be.
Sure, and maybe even then I can disclose the secret location.
Okay, all right. Until then, we're sworn to secrecy. Ladies and gentlemen, Christian Vang has been our guest. He's an engineer with ESPN, and he's been putting in, among many other things, putting in a phone system that works across the country with different talent and call screeners and board operators in different locations, and talking to us about his notions about education, self-education, and finding out what's the next technology that you need to know about to get yourself up to speed on. Our show's been brought to you by Telos and the Telos VX, not quite coincidentally. I planned that. So if you want to find out more about SIP technology and the Telos VX, you can go to the website, telos-systems.com/VX. So there you go. Our show will be in the show notes, some of the resources we mentioned. And I encourage you to go to either the gfqnetwork.com website or thisweekinradiotech.com. From either location, you can watch or download or listen to, or most importantly, subscribe. Use your favorite podcast catcher. There's one that, of course, a lot of folks use iTunes, and that works just fine. I happen to like this one called Beyond Pod. It's good for audio and video podcasts as well, and I guess they have it for I know they have it for Android because there you go. I've got it on my Android. But check it out, Beyond Pod. I think you're going to like it. The important thing is subscribe, and that way they show up in your inbox or on your application automatically, and they're available for you to listen to the latest episode on your drive to work or when you're going to sleep. Thanks to Andrew Zarian at the GFQ Network for producing the show, and again for Telos Systems for sponsoring it, Christian Vang for being our guest. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another tort has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.